So to get started, let's go ahead and solve this first equation. 2x equals 12. Now to solve, we have to get rid of times 2, so we need to divide 2. And of course, we do the same thing on both sides of our equation. So this side gives me 1x, which is x, equal, and 12 divided by 2 is 6. So the solution to this equation is simply x equals 6. And if I go to the number line, I find 1, 2, 3, 4, 5, 6 is right here. So I could just put a dot either on the 6 or above the 6. Why don't I put it just above it so we can still see right there? That would be representative of the solution to this problem. Let's go ahead and solve another one. All right, here's another equation. You know how to do this. To get rid of divide -2, what do? Multiply -2. On both sides, of course. On the left, we get r by itself. On the right, we get -8. And in the middle, we have an equal sign telling us r is equal to just the number -8. So let me go to my number line. The solution would be -1, 2, 3, 4, 5, 6, 7, 8, right there at -8. That is the single solution to this equation. Okay, now let's look at this one. First of all, let's go ahead and solve it. I have to get rid of times 3, so what do? Divide 3 on both sides. Now this side gives me my 1a like I want, which is a. This side gives me 4, and I bring down the sign. But wait a second, this doesn't look like the other ones we solved. Problems A and B were equations, so they had equal signs in the middle. This one has a greater than sign in the middle, so it is called an inequality. They're not equal. A is not equal to 4. It's getting eaten by that hungry alligator, so it's actually bigger than or greater than 4. So now when I think about the solutions, let's think about things that are bigger than 4. I mean, for example, isn't 5 bigger than 4? How about 11? Isn't 11 bigger than 4? 5 is bigger than 4. 11 is bigger than 4. How about, I'm out of space. How about 20? Isn't 20 bigger than 4? Well, all of those things that are bigger than 4 would be over here to the right of 4, wouldn't they? But 4 itself is not actually one of the solutions, so that's why I'm not putting a dot at 4. I have an open circle. So this time, everything to the right of 4 or greater than 4 is a solution, but not 4 itself. So notice with an inequality, I solved it just like an equation, but the meaning of the answer is different. Let's do another one. This one says y plus 7 is less than -8. Okay. Line through the sign to separate the sides. We get rid of -7 by doing add 7. Well, here I have y plus 0, which is just y. Over here, -8 plus 7 becomes -1, and my sign comes down. So I have y is less than -1. See, this time, the number is getting eaten by that hungry alligator mouth, meaning it is larger than our values for y. So the values for y must be smaller than -1. So if I think of things that are smaller than -1, they have to have even less value. How about -20? Wouldn't that be even less than -1? Or how about -5? Isn't that less than -1? And you know what? They don't always have to be nice, pretty integer numbers. How about -7.2? Isn't that also further negative than -1? So on a number line, the solution would be, we go to -1, and we do not include it as one of our solutions because it's only numbers that are less, like -2 and -3 and -5 and -20 and -7.2, right? All of these things are to the left of -1 on the number line. So this is how we're going to approach inequalities. We solve them just like equations, but the meaning is different. So we have this little reminder slide for you right here. Inequalities, we solve them like equations, but the meaning is different. You have to always think about the answer. And when you think about it, there are an infinite amount of solutions. An infinite amount of solutions. That's mind-boggling. So that's why we have to represent the answer on a number line with an arrow in the direction of all of our values for x. So this concludes our notes on inequalities.